And Python's got this another built-in test where you use assert and your function name, and then you would use the equivalent with the correct result. And normally you would use multiple assertion tests to check whether your function is actually giving you the right amount. Okay. So again, here I would assert using the function name, which is this nucleotide content, and I would then check if the G and the C actually in this DNA string makes up. I would tell it that by looking at this, the GC should make up 50% of the string, and I would give it the correct result, so that it can use that sort of as, it's almost like machine learning. It's kind of using that as a background test to make sure that it's also doing the calculations correctly. Now, for example, here it may not make much sense, but we're kind of getting to something. Okay, so then if you call it, it will give you the correct result, or you would hope so. Now, this is the example I wanted to show. For example, here is showing what basically we've designed it so that the next test, like I said before, we need to anticipate what kind of mistakes the user will make, or we need to anticipate what kind of data they will give us. They will give the function, and sometimes that usually, as in bioinformatics, that data is not very clean. So what do we do with the type of things that we will get when the data is not clean? And sometimes with DNA sequences, the DNA sequence might have these ends in it, and many other things if you're working with protein sequences. So you need to be able to, for example, tell this thing, you might, for example, say that we're going to ignore these ends and only calculate it out of this, that's actual nucleotides, or I want to consider those ends as well. But those are all what you will decide. Okay? And again, you can decide that sometimes it's mathematically incorrect, but that's how you do it in biology for one reason or the other, or you have a reason for why you want to do it that way. But these tests have to be designed by you to make sure that they are giving you what you want. So here, I said the function below should fail the assertion test because the GC content makes up more than 50% here. So you can also check whether your assertion test is correct. So here, this thing is going to calculate this. You've told it that the GC content is 50%, but it's looking at this and it's going, this is not 50% because I've got multiple ends over here. Okay. So how do you deal with something like this? How do you deal with a user giving you ends and the machine, in this case, for example, you wanted it to say it's 50% because you wanted it to ignore that, but you haven't told it how to ignore it. Okay, so that needs to go into the design of your thing. So you can either, like I said, choose to exclude the ends when calculating the percentage of GC content, and that is usually not how we do it. It's not mathematically correct. But you could, for example, say DNA.replace, when it sees a big N, replace it with nothing. In other words, remove the N. And if it's a small n, also remove it. So I've just added those two lines. And then if you do your assertion test, then it should be fine. It's now blatantly ignoring any ends that might be part of the DNA and calculating in this case, your GC content. It's calculating it only out of whatever is not an N. Okay? And like I said, or you could leave that in because that is the correct way to do it, and then calculate the correct amount that this should be. Remember, you should give a correct value here. So here you've got 14 nucleotides, and your GC makes up 2 divided by 14. So you should say that this should give you 14. And then it should work. Okay, and like ideally you would want multiple assertion tests, so that the like machine learning, the machine is better able to calculate how to do the formula or the math correctly.